Hello everyone, and welcome to another GIS mathematics tutorial video. In this video, I want to go through another example of using this new way that we talked about in the previous video to generate the area of a polygon given its coordinates. And so in our last video, just to recap, we did a triangle. To sort of prove that this extends beyond 3 points, I want to go through in this video and I want to do a square. Now, I know it may not look like a square on your screen here, but just sort of looking at the points, right, hopefully you'll see that this is actually a square and that the image has just been stretched slightly in the way that it was cropped. So anyway, we have a 2 by 2 square, which would mean that the area that we are looking to get is hopefully going to be 4, right? 2 times 2 is 4. But let's go ahead and let's use that equation that we used before. So we have A, B, C, and D. So that equation, just to sort of recap ourselves, is 1/2 times the absolute value, and we start with the first x times the second y, plus the second x times the, that should be a B, times the third y, plus, in this case, because we have more points, right, we now are going to go to the third x, which is x sub c, times y sub d, plus, and then we do x sub d, right, but because we can't go any farther, there's no point e, we wrap around and we do y sub a. And then we subtract from that. I'm going to move down here so we have a little more room. We flip, and now we start with the y's. So the first y times the second x plus the second y times the third x plus the third y times the fourth x plus, again, now we do the fourth y, and we wrap around to that first x, right? And then again, absolute value. So let's really quickly go ahead and do this equation. All right, so we have this first part here is going to be xa is 2, yb is also 2, plus xb is 4, times yc is also 4, plus xc is going to be 4 times y of d is going to be 4. And again, I'm just going through finding the letter I need to go to for the point and then pulling up the coordinates. So this 4 is coming from the x coordinate of the c point, and this 4 is coming from the y coordinate of the d point. Okay, plus, and now we're hitting the x coordinate of d, which is 2. And then because we've hit the last point, we have to wrap around and grab the y-coordinate of the a point, which is 2. Okay, so we can do the math, right? That's 4, 16, 16, and 4. Right, so that's going to be 20 plus 20, and we're going to get 40. So that's this first half here. The second half, right, is going to be, now we're going to start with the y. So this is going to be y of a is 2, x of b is 4, plus y of b is 2 times x of c is 4, plus y of c is 4 times x of d is 2, plus y of d is 4 times x of a is 2. And now we're going to do the math, right? That's 8, 8, 8, 8. So that's 16. 16 is going to be 32. All right, so now we subtract, right? Let me scroll down just a little bit so we have a little bit more room here. All right, so we're going to take 40 minus 32 is going to be 8. All right, we take the absolute value, which in this case doesn't change it. The absolute value of 8 is still 8. Divide that by 2, because again, scrolling back up for a second, right, this whole thing is divided by 2. Divide 8 by 2, and that gives us 4, which again, if we scroll back up, that's the area that we were looking for. So I know this one was a little bit faster than the previous one, but that's just because I wanted to sort of hammer in how we get this equation and just prove to you that it actually does work with more than 3 points. And again, we could have a 4th point, we could have a 5th point, right? We can move these points around, right? It doesn't have to be a triangle or a square. You could have a pentagon, you could have a convex polygon, a concave polygon. Right? I could have a polygon that looks like this. Right? Assuming that as long as it doesn't cross back in on itself, right? We can get the area of this polygon as long as we know the coordinates of all the vertices, right? This is a completely legitimate polygon that we can calculate the area of using this equation. Now, I will say this from a human perspective, right? This equation is obnoxious, right? XAYB, XBYC, XCYD, right? This gets really obnoxious for humans. But for computers, this is actually really easy to calculate. And this is how, again, this is how a GIS system would calculate the area of any polygon given just its coordinates. So hopefully this makes sense. Again, if you have any questions, please reach out. Thank you.